Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, welcome again to the TV learning program. Today I will be with senior 5 students on unit number 6, and the lesson will be the exercise. We have discussed a lot so far in unit number 6, and I have thought that it is really necessary that we go through some exercises to let you know the kind of exercises we deal with in this organic chemistry, and so that you can get time and you try them. So the exercises we have here, they are in two parts. And part number 1, you can see here we have the preparation of compounds. We start with a given type of compounds so that we can transform it into another compound which is needed. When you are in your lab, you may need to use some compounds which are not available in the lab. And in that case, you will have to prepare them. So the first part of the exercise will be the preparation or the conversion, how we can convert substances from one form into another form. And the second part will be a question in the type of a problem. And in this type, we will analyze the question, read the information which is provided, and then we use it to identify the compounds which have been described in the problem. And for the third question, which is this one, we will name and write a mechanism. It is also one of the types of questions we deal with in organic chemistry. So let us go back and we start with our exercise. Part number 1. How can you perform the following conversions? Conversion number 1, it is from propane 1-ol to propanol. Question number 1, we're moving from propane 1-ol to propanol. To propanol. So let me invite you to take your books and the pens and try to write the structures of these two compounds. Because if you want to prepare a compound from another one, then it's always better if you start with the structures. And then from the structures, you will check on what is to be done, what you can do so that you can transform one structure into the other. Here we use the chemical properties we have covered. We use the preparation methods we have covered in the previous units. So think about the structures of the two compounds, propane 1-ol and propanol. Propane 1-ol is this one, CH, 3CH2, CH2OH, and we want to transform it into CH, 3CH, 3 and oxygen here, propanol. So how can we transform this alcohol into this ketone? The changes we have here, there are two. This is in the oxidized form. From the alcohol to get a carbonyl compound, you need to oxidize. But there is something very important we have to deal with. The alcohol we have has the oxygen on the first carbon atom. And in the compound we want to produce, the oxygen is on the second carbon atom. So the first thing to be done before we can proceed with the oxidation is to move or to change the position of that OH. How can you come up with that? Changing the position of that hydroxyl group. Remember, when we take an alcohol and dehydrate it, we produce a double bond. And if we rehydrate the product we get, the double bond, what will we produce? Do you remember the Markovnikov rule? Following the Markovnikov rule, we will produce a secondary alcohol. So we proceed like this. CH, 3, CH2, CH2, OH, and we add H2SO4 for dehydration with some heat. What do we produce? We produce CH3, CH, CH2 plus H2O. So we have the ketone. Sorry, we have the alkene with a double bond. And from the double bond, CH, CH2, if we add water again, what do we get? Remember, the addition of water to a double bond is always carried out in the presence of sulfuric acid. And what do we produce? We produce CH3, CH, CH3, OH. Now we have our secondary alcohol. Secondary alcohol. And from the secondary alcohol, if we oxidize it, we will immediately get the ketone we want. So from the secondary alcohol, CH3, CHOH, and CH3, we use a mixture like potassium dichromate in acidic medium, and we heat to produce CH3COCH3. This is the main compound we want to get. So we have already prepared our ketone from the alcohol. And I think everything is clear. Good. Now let us go to the second question. We have propane 1-ol, the same starting material, or the starting substance, and we want to produce butane 2-ol. And as I said, it is always good to start with what? To start with the structures. So the compound we are starting with is CH3, CH2, CH2OH. And we want to produce CH3, CH2, CH3, and here we have OH. So again, it is a secondary alcohol we want to produce, but from a primary alcohol. So we have to find a way of moving the OH group. But there is another thing which is new in this question. Here we have 3 carbon atoms. And here we have 4 carbon atoms. So how do we increase the chain? We have to increase the chain. This time there is no oxidation, but we have to increase the chain. Some of the reactions we have seen in carbonyl compounds have shown that it is possible to increase the number of carbon atoms in the chain when you use, for example, a reaction of a Grignard reagent and a carbonyl compound. So how can we get a Grignard reagent from the compound we have here? And how can we get the aldehyde or a ketone from a Grignard reagent, so from this alcohol we have here? So we have CH3, CH2, CH2. We dehydrate the compound to produce what? To produce a double bond, and from the double bond we will oxidize the ozonolysis to produce an aldehyde. So if we add H2SO4 as a dehydrating agent, we get CH3CH, CH2 plus H2O. And from this alkene, we can produce 2 aldehydes. if we treat this compound with ozone followed by H2O, we produce CH3COH plus CH2O. Plus CH2O. And from there, we have two compounds, one with two carbon atoms and another one with one carbon atom. And remember, in the compound we want to produce, we have 4 carbon atoms. So the only way we can get the 4 carbon atoms is to use a compound with 3 carbon atoms, and we add another compound. We find a way of reacting it with another compound which has 1 carbon atom. So what do we do here? Here we have CH, 3 CH2, CH2 OH that can be transformed. If we use HCl in the presence of zinc chloride, we produce CH3CH2, CH2, chlorine, and H2O. And then the compound, we can transform it into a Grignard reagent if we add magnesium in ether, dry ether, and we produce CH3CH2, CH2, Mg chloride. We have our Grignard reagent. And remember, what we want to produce is a secondary alcohol. So how do we proceed to produce a secondary alcohol? To produce a secondary alcohol, we have to use, remember, we have covered this in the preparation of alcohols. We said that we can only produce secondary alcohols from Grignard reagents if the Grignard reagents are reacted with, primary alcohols, but the alcohols which is not primary, let us say aldehydes. When we take an aldehyde plus a Grignard reagent, we produce a secondary alcohol. So, do you think the products we have here, this one, for example, this one and this one, do you think they will be useful in our preparation? Because remember, we need an aldehyde which is not methanol, and we need a Grignard reagent. So let us use this compound and find a Grignard reagent. From CH2O, if we reduce it, lithium aluminium hydride in ether, we produce an alcohol CH3OH. And the alcohol we have here can be transformed into CH3Cl if we use a mixture of HCl in zinc chloride, we produce CH3Cl. And from CH3Cl, if we add magnesium in dry ether, we produce CH3MgCl. Now we have a Grignard reagent we can use. Now, how do we transform this one to get an aldehyde we need? So we have this one which will be oxidized, CH3, CH2, CH2OH. We use a weak oxidizing agent, or we can distill off The oxidation gives us CH3, CH2, CHO. And the CH3, CH2, CHO, if we add CH3 MgCl, and we treat the product with water, we get CH3, CH2, CO, with hydrogen here, this hydrogen we have, and the CH3 from this Grignard reagent, and because of the treatment with water, we produce the alcohol plus a byproduct which is chlorine magnesium hydroxide. So we have our final product. And I did this to show you that you have to always be very careful, because some of the compounds you will produce may be useless. Like this one, for example. We immediately proceeded with the production of some compounds, but which have ended up becoming useless. So you have to think and rethink, okay? Think twice before you decide on what is to be done next. Here we have more exercises. Transformation of propane to all to CH3, CH, CN, or H. Do you remember the reaction of aldehydes or ketones with hydrogen cyanide? Well, remember that reaction. And you also remember the name of the involved mechanism, nucleophilic addition. And we have another exercise here. From propane, try to prepare methyl propane to all. So we have those two more questions which you are going to try. Please let me give you some seconds and you note them down. So I've shown you how you can work out these questions. So you write down those two questions and you will try them yourself. Like 30 seconds, you will be done. And we go to the next slide. Good. Hope you're done, and we go to the next question. The next question, I read, 3 alcohols, A, B, and C, of molecular formula C4H10O were separately heated with acidified potassium dichromate. Alcohol C didn't undergo any change, while A and B did. Those are the information we have to analyze. Every sentence, every statement which is in the question has something very important to tell us. So we should be very careful with everything which is said there. And alcohol A produced compound D, which reacted further to form compound E. And the dehydration, followed by rehydration of compound A, produces alcohol C. Alcohol B reacted to form compound F. Compound F didn't react with Fehling solution, but reacted with 2,4-dinitrophenohydrazine. Questions? Suggest a structure formula of C and give a reason for your answer. Next, give the structure formula of compound D and F, and the structure formula of alcohols A and B. Write the structure formula of the product formed when compound F reacts with 2,4-dinitrophenohydrazine. Now let us analyze our question so that we can start to answer those sub-questions. It is said that we have 3 alcohols with this molecular formula. This is second part. So we have C4H10O. Because we have alcohols with a very small structure formula or molecular formula, then we can draw all of the isomers. It is very simple. We can draw all of the isomers, and then we will be choosing the isomer corresponding to each letter as it corresponds to the descriptions we have in the question. So the possible structures, we have CH3, CH2, 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 OH. The second one, this is primary. We can have the secondary, CH, CH3, OH. And we go to the tertiary, CH, the third, sorry, CH, CH2, OH with a branch, and then we move the OH to have CH3, CH3, OH. So those are the only possible isomers we can have with that molecular formula. Now let us analyze. It is said that all of the alcohols were separately heated with acidified potassium dichromate. Do we all remember what it does? Which reaction is being said there? It is an oxidation. And we know that some of the alcohols are not oxidized. The alcohol C didn't undergo any change. So that one is a tertiary alcohol, and it will be this one. Tertiary alcohols, they are those ones which are not oxidized. So we have C. This is the alcohol C. And it is also said that A and B did change. So A can be this one, B can be this one, A can be this one. So all these will undergo a change. They can be oxidized. So we have to go on with more statements in the question to identify which one is A, which one is B. Alcohol A produced compound D, which reacted further to form compound E. We know that reaction. We have seen that a given class of alcohols is able to be oxidized, and the product which is formed can undergo a further oxidation. Which class of alcohol is that? It is a primary alcohol. Primary alcohols can be oxidized to aldehydes, and aldehydes can undergo further oxidation to carboxylic acids. So this one can be A as well as this one. So that is the compound A. Alcohol A can be this one or this one. So let us have a look at what is explained in the next statement. It is said that, if we read here, it is said that it produced compound D, which underwent further oxidation to produce E, but the dehydration of A followed by rehydration produced compound C. So from this one, if we dehydrate CH, CH2, OH, and CH3, if we remove H2O, we produce CH3C, CH2, and CH3. What do we get if we add more H2O? To the product, we get CH3, 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 and OH. So this is the compound which is A. That is A. Because if we dehydrate it and rehydrate it, we get C. And which one will be? Compound B. Alcohol B reacted to form compound F. F didn't react with failing solution. We remember which class of carbonyl compounds do not react with failing solution. Those are ketones. And if we oxidize a secondary alcohol, we produce we produce what? We produce ketones. So this B, the compound here is B, and it produces compound F, which is the ketone. Okay? So I hope that we have answered question number 1 to give the structure formula of C, because it is the one which doesn't undergo oxidation. We have given the structure formula of D and F, and we also know the structure of A and B. And when F reacts with 2,4-dinitrophenohydrazine, that is a simple completion of an equation. We remember Brady's reagent, the simple completion of the equation. You can do that. It's very simple. So you will try the remaining question, this one. You write the structure formula, and even the mechanism. You have seen that in the previous lessons. So the writing a mechanism is not very difficult. And as we are approaching the end of this lesson, let me go to the homework that you will also try and explain what you have to do. An organic compound A, the compound A of molecular formula C8H18 oxygen, was oxidized by heating it with acidified potassium dichromate to produce B of molecular formula this one. B could not undergo further oxidation. I said you have to be very careful and get to know the meaning behind each statement. B could not undergo further oxidation. What does it mean? When A was heated with aluminum oxide, it produced a compound C. The ozonolysis of C gives only a compound D. We know compounds which can undergo ozonolysis. And then D gives a positive test with failing solution. Write the structure formula of compounds A, B, C, and D. You will try that one. I hope in the next session I will give you the compounds so that you can check if you did it well. So this is the end of our lesson. Thank you very much for your attention. See you next time.